class, Professor Smith here, excited to create a video on composition of two functions basic. Suppose that the functions q and r are defined as follows. Q of x is equal to x squared plus 4, and r of x is equal to the square root of the quantity x plus 5. Find the following. R composed with q of 4, sometimes read as r circle q of 4, and then also find q composed with r of 4, or q circle r of 4. Before we start, let's begin by reviewing the terminology for a function. When you select the link for functions on ALEKS, it will open up the dictionary. Here's the definition that we see on ALEKS. A function f is a rule that assigns to each element x in a set A a unique element y in a set B. So imagine, if you will, we have this function box. We're going to have an element x drop into the function box. If we call our function f, what will come out is a y value, and we usually designate that y value as y equal to f of x. In fact, for this particular problem, we want to find the composition evaluated at 4. So I'm going to change my x from an x to a 4. And then what will come out will be an f of 4. So let's change that to f of 4. A composition says, now let's take a look at another function box. So let's add in a second function box. And now we're going to call that second function box, we'll call that guy g. And what's going to pop in now is the output from our first function. So f of 4 will now be the input, and then what comes out will be g of f of 4. Notice that the input is always on the inside of the parentheses, and the function g is on the outside. So let's go ahead and begin our problem. For our example, we want to find r composed with q of 4, and we can rewrite that as r of q of 4. Notice that the first function r is outermost and the second function q is innermost. It's almost as if you removed the composition and instead introduced a set of parentheses. All right, so we're going to do the inside function first. That's q of 4. Recognizing that q of x is equal to x squared plus 4. So therefore q of 4 is 4 squared plus 4, which is 16 plus 4, or 20. So now we can rewrite this as r of 20, because I've replaced q of 4 with 20. Now we'll do the next step and compute r of 20. Recall that r of x is equal to the square root of x plus 5. So therefore r of 20 is going to equal to the square root of 20 plus 5. Order of operations says you should do what's in the parentheses first, and you can think of the square root as the parentheses raised to the 1/2. And so when we do what's inside the parentheses, we'll take the 20 plus 5, which is 25, and the square root of 25 is equal to 5. So our answer is equal to 5. For the second part of our problem, we're going to find q composed with r of 4, which we can also write as q of r of 4. Starting with the inside function r of 4, we know that r of x is the square root of x plus 5, so therefore r of 4 is equal to the square root of 4 plus 5, which is equal to the square root of 9, and the square root of 9 is 3. So we'll replace r of 4 with 3 in our expression q of r of 4. That'll give us q of 3. We know that q of x is equal to x squared plus 4, so therefore q of 3 is equal to 3 squared plus 4. When we square the 3, we get 9, and 9 plus 4 gives us 13. So therefore our answer is equal to 13.